Welcome back, everyone. Patrick here, moving on to another question dealing with factoring. So here we're told a cylinder has a radius r and a height h, and then we're told after the radius is decreased by a certain amount, the cylinder's new volume is given by this expression, pi r squared h minus 8 pi r h plus 16 pi h. And with that information, we have to figure out what was the decrease in radius, volume, and surface area. So this is a pretty cool question. Now, as a quick reminder, when we're dealing with a cylinder, what is the volume of a cylinder? Well, it's basically pi r squared h. And then we're also going to be dealing with the surface area, and we know the surface area is 2 pi r squared plus 2 pi r h. Another way you could represent the surface area if you want, you could factor out a 2 pi r, and you're left with an r plus h in brackets like that. So either of those work. So we're going to be using these formulas throughout the question. Now, we're told that a cylinder has a radius r and a height h, which is nice because those are the variables that we're used to when we're working with this formula. So as of now, this cylinder, if it has a radius r and then a height h, it has a volume pi r squared h, like that. Now we're told that the radius is decreased by a certain amount. So if we have a radius r right now currently, and then we decrease the radius by a certain amount, let's say we decrease it by m units, then this here is going to be the new radius. And so the new volume, if we decrease the radius by this amount, would be pi, that new radius squared h. The height doesn't change, so the h stays there. Okay, so the new volume would be in this kind of format if we decrease the radius by a certain amount. Now, what's nice is we're told that the cylinder's new volume is given by this expression. So if we write this expression over here, pi r squared h minus 8 pi r h plus 16 pi h. We're told that the new volume is this expression over here. But we also know just in general, if we forget about this expression we're given, just in general from up to this point, up to this word amount, given just that information, we know that we're dealing with this kind of scenario. So what we can do is see if we can take this expression, put it in this kind of format, and then hopefully get that m value. Then we could tell what the radius decreased by. And then once we know what the radius decreased by, it will be easier to find expressions for the decrease in volume and the decrease in surface area. Okay, so let's try to get in this format. How do we do that? Well, we got to take this and factor it, because notice here we are adding and subtracting expressions versus over here we are multiplying expressions. So we want to get an expression here where we're multiplying factors, and then hopefully it will be in that same format. So first thing we look for, can we factor something out? And notice that in all of these there's a pi, that's common, and notice there's also an h, that is common. R is in both of these, but there's no r over here, so we can't factor out an r. So we could take out a pi h initially, and then what would we be left with? Well, we would just divide all of these values by pi h, what we took out, and we'd be left with an r squared minus 8r plus 16, like that. Okay, and then let's see if this bracket will factor further. So let's see if it'll factor by decomposition. Notice we can't take anything out, so if we go straight into decomposition, that a value is 1, the b value is -8, the c value is 16, the ac value would be 16 times 1, which is 16, and then we got to find two numbers that multiply to 16, add up to that b value of -8, and those two numbers would be -4, -4. Okay, so notice that we're dealing with a perfect square trinomial. These two numbers are the same over here. So we'd have r squared minus 4r minus 4r plus 16. From these two could take out an r. From these two could take out a -4. And then notice we could take out an r minus 4. And what are we left with? R minus 4. So this ends up being r minus 4 squared, like that. This bracket factors into that. Both of these are the same thing. So going back to this over here, we'd end up with pi h, and then this is going to be r minus 4 squared, like that. And so now notice this and this, they're the same format. What we could do is we could actually switch the h and the r minus 4 squared to put it in this order. If we take this, rewrite it just on the bottom here, we'll have r minus 4 squared, and then we have the h value over here. So I just switched both of those. And now comparing these over here, notice how many units was the radius decreased by? Well, 4 units, right? It's easy to tell that the m value here is 4. Okay, so the radius started with an initial amount of r, that's what we're told, and then it was decreased by a certain amount to get this new volume. The amount it was decreased by was 4. We could tell from this bracket over here. Okay, so hopefully that makes sense so far. So we answered part of the question. So the decrease in the radius is equal to 4. Okay, now we have to find the decrease in volume and the decrease in surface area. Actually, the surface area is going to be tougher than the volume. What's the decrease in the volume going to be? Well, it's just going to be the change in the volume. And it's basically going to be the, so if something goes from like 10 to 6, notice how the decrease here is 4. So what we do is we take the old amount and we're subtracting the new amount to get the decrease, if that makes sense. So what we're going to be doing here is we're going to be taking the old volume and then subtracting the new volume. So maybe I shouldn't put change in volume here. Maybe it's better to put decrease in volume, because just in general, whenever we're dealing with a change in something, it's always the new value minus the old value. Right? That's the change. So like it would be, if we go back to this example, it'd be like 6 minus 10, which would give us -4. So that shows us that it decreased by 4, but we don't say there was a decrease of -4. We just say there was a decrease of +4, right? We take like the absolute value of that. So we're not really using the change, we're finding the decrease. And if something decreases, to get that value, that decreased value, we take the old minus the new value. Okay, instead of using this change over here, which is usually new minus old. Hopefully that makes sense. We're trying to get just that absolute value. If we do new minus old, we're going to get a negative value over here. And usually that's not the answer. That would be in the back of a textbook. They're asking for the decrease in volume. So we're going to do old minus new. And we have everything we need. We have the old volume, which was just based on the radius r and h, so that's just pi r squared h. And then we also have the new volume. Now this new volume, there's actually two choices that we could use, because we're given this expression over here, but we're also given, remember we factored this, right? This and this are the same thing. If you expand that, you would end up with this. So the question is, would we want to plug in this or plug in this, the expanded version? And because we're going to be simplifying anyways, we would have to expand this anyways. I feel like it's better to plug in this amount over here, right? This whole thing for that new volume. So we're going to be subtracting that entire new volume, but that has to go in brackets. So just be careful here. You're subtracting that whole new volume. So we got to put this expression in brackets in this calculation. So we end up with pi r squared h minus 8 pi r h plus 16 pi h, like that. Then we can distribute the negative inside the bracket. So we'd have pi r squared h minus pi r squared h plus 8 pi r h. Basically, all of the signs change like that. These cancel out, and we're left with 8 pi rh minus 16 pi h. So that ends up being the decrease in volume. So that's the expanded version. You could also factor this. Notice you could take out an 8 pi h from both of these. And if we take out an 8 pi h here, we're just left with an r. Here we'd be left with just a 2, like that. Okay, so this decrease in volume, we can say it's either this, let's write it on the side here, or the factored form, which would be that right there. All right, so that is the answer for the decrease in volume. Now, the tougher part, it's not too tough. It's just going to be a little bit more algebra. We got to find the decrease in surface area. But the same thing is going to apply. So the decrease in surface area is going to equal what? How do we get the decrease? Well, we take the old surface area and we subtract the new surface area. Now, surface area, as a quick reminder, is that formula right there for a cylinder. Now, with a cylinder, the old surface area, the cylinder had a radius r and then a height h. So it's basically just this amount. Like that. And then the new cylinder, give me a sec here. Yes, we're all good. The new cylinder, remember the new cylinder, it has the same height, but then it has a radius of r minus 4. And so the same h stays the same here, but instead of this r here, we got to plug in r minus 4 for that new surface area. So we would go minus, in brackets, the new surface area would be 2 pi r minus 4 squared plus 2 pi r minus 4h, like that. Okay, so now from here, what we want to do is expand all of this and simplify. So bringing that calculation over here, just to give myself some room, next step would be, notice here, we can get rid of this bracket because there's nothing in front here. But over here, for this bracket, we got to distribute that negative inside both of these expressions. So we'd end up with minus 2 pi r minus 4 squared minus 2 pi r minus 4 h, like that. Now, to make things easier, notice that in all of these, there's a 2 pi. Okay, so instead of expanding everything with the 2 pi, because it's common in all these, we could just take the 2 pi out from everything. And what would we be left with? R squared plus RH minus R minus 4 squared minus, let's bring the H in front here, so it would be HR minus 4, because we're going to have to expand that H inside the bracket. Right, so basically from all these, I just took out a 2 pi, just to make the calculation here easier. Now, r minus 4 squared which is r minus 4 times r minus 4 is just r squared minus 8r plus 16. Okay, so this over here, just be careful. I'm trying to be careful here as well with all the algebra. This, we're subtracting that whole thing. So we're subtracting that whole thing. Like that. So this changes to that. Then over here, let's distribute that negative h. So we'll have negative hr plus 4h. And then we're going to close that bracket. Yes, looks all good to me. So from here, what we do, r squared plus rh, this negative distribute in this bracket. So lots of algebra here. I told you that that decrease in surface area is going to be more tricky. To be honest, usually maybe a question like this, they might only ask for the decrease in radius, right? They may not even ask for the decrease in volume or surface area. It's a little extra, but just in case you maybe run into something like this, or just to show you that you can make these questions more complex if a textbook only gave that question. Okay, so from here, what I'm going to do, let's just check the steps here quickly. Looks all good to me. What we got to do is simplify this bracket here. So the 2 pi is still going to be on the outside. Now over here, the r squared minus r squared, those cancel out, which is nice. Then we have an RH here, we have a minus HR. Those are the same thing, right? This we could just switch the R and the H. So here we'd have an HR, here we'd have an HR, or we could switch these two and put an RH here. So this and this cancel out. And then we'd be left with 8R plus 4H minus 16. So like the decrease in volume, I am going to give both a factored form and then also an expanded form. I just want to make sure that I got everything before I erase. Yes, we're all good. So over here, notice that in terms of factoring, we could factor this bracket further. We could take out a 4 from all these. And if I take out a 4, actually, let's just do it in steps. So if I take out a 4 from these, then I'd be left with a 2r plus h minus 4. Like that. And the 4 and the 2 we can multiply. So we'd have 8 pi 2r plus h minus 4. So that there is one format that you can represent the decrease in surface area by, or if you want to expand, you could take the 8 pi expanded in the brackets, so we'd be left with 16 pi r plus 8 pi h minus 32 pi. Like that, right? That's another format right there for that decrease in surface area. Okay, so fairly tricky question. Lots of algebra, at least. The most important part was taking this, taking the new volume, factoring it, and then noticing that you got that r minus 4 squared there, and then realizing that the decrease in radius was 4 then. And then from there, you could find the decrease in volume and surface area by just doing algebra.